So when you're graphing these things, if they hit nicely, then it's easy to do. But they don't always hit nicely, and sometimes it's weird. And in the real world, we're going to get into that. They're going to be ugly. So there's other methods. Another method is what's called the substitution method. And this is a method of solving. So you substitute one equation into the other. So you find out where they're equal, and then you're able to solve. So you can solve one equation for either x or y. I'm going to show you. I always try to pick the easiest variable, the one that doesn't have a number in front of it, because then there won't be any fractions. Once you get that, you substitute this, okay, this expression into the other equation, and you solve. And so you're going to get one of your answers. After you do that, you're going to substitute your answer back into either equation, and I just put it into the one that I solve. I put it back into this one, and then you're going to solve so you get the coordinate. So these lines, I could graph them. If you look at example 1, I could graph them, but they're both equal to y. So if they're both equal to y, then, and I want to know where they're equal to each other, can't I take this, and I'm going to box it, can't I take this, and since that's what y equals, can't I substitute it in for this y? So I would substitute it in. I would get 2x minus 5 equals 4x minus 1. Now, some kids see stuff like that, and they are like, where did your y go? Okay, well, my y, it's substituting. So like if I had a substitute teacher, I would not be there anymore. I would be gone. So I'm substituting the 2x minus 5 in for the y. It's becoming that y value. Okay, so now what you're going to do is you're just going to solve. You're going to take that thing and solve. They're selling football cards, so I put money on there for when they ring the doorbell.
Money where?
On the table.
Okay.
Yeah, I don't know if they come and ring the doorbell. Sorry, I'm just moving downstairs and I don't want to stop the video because then I have to start all over and I don't want to do that. All right, so with that being said, I'm going to take this thing and I'm going to solve, right? So when I solve, I just get my x's together. So I'm going to minus 2x. And I get a negative 5 equals 2x minus 1. I'm going to add 1 and divide by 2. So x equals a negative 2. So the coordinate x equals a negative 2 in that coordinate. Now this is the part that I kind of cheat on. The one I boxed, I now know this is what x is. So I'm going to substitute it back in there for x, and it will allow me to find y. So when I substitute it back in for x, I get 2 times, my answer was a negative 2, minus 5. Well, that's a negative 4 minus 5, so my answer is a negative 9. And if you think about that, that's a little bit farther away, so like you would need a big graph square to be able to find that. So it's kind of nice to find these a different method if you can. All right, so if you look at the next problem, they're not both set equal to y, but this one is set equal to y, and y equals 6x. So I'm going to take this 6x, I'm going to box it, and I'm going to put it in for y. So I'm going to rewrite this as 2x plus 3, and then wherever you're substituting, I would use parentheses. It will just help you in the long run. So instead of writing a y, you're going to write a 6x. The y is gone. You are substituting. Okay, so what I would like is just solving. So 2x plus 18x equals a negative 20. Like terms, 20x equals a negative 20. Divide by 20, and x equals a negative 1. So I know my x value is a negative 1. Okay, so now what I can do, since I know this, I can take it and substitute it back in there. So I'm going to have 6 times a negative 1. That's what y equals. So my y answer is a negative 6. So this, if I graph these two lines, if I would have solved the other one, I would have gotten that. But then I don't have to solve. Okay, so I would like you just try one of these. Okay, just try this number 3. I would like you to try number 3 and see if you pause the video, see if you can get it to work. Pause. All right, this is set equal to y, so I'm going to substitute it in for this y. So I would have, 3x plus 8 parentheses. Now instead of writing y, I'm going to write x plus 9. And the whole rest of the equation stays the same. So the first thing I do is multiply in 3x plus 8x plus 72 equals a negative 5. These are like terms, 11x. I can minus 72, and I get a negative 77. Divide by 11, and my x answer is a negative 7. So that goes here. X is a negative 7. Okay, and so I'm going to take that negative 7, and I'm going to plug it back in there. And I'm not even going to write this down. I'm going to do that in my head. Negative 7 plus 2, plus 9 is 2. Done. Okay, I don't need you to show me every single little step. Okay, now the reason I didn't want you to do 4 is because I wanted to show you, like, we've been solving for y, but why do extra work? This one is solved for x, which is totally legal. I don't really want to have to do extra work. Like, the least amount of work for me is perfect. So that's what x equals. So I'm going to put that in for x. So I'm going to write 2 parentheses, 4y plus 7 minus 6y equals 12. So I'm writing this whole equation the way that it was written, except where there's an x, I'm going to write a 4y plus 7. So I multiply in, that's 8y plus 14 minus 6y equals 12. Like terms, that's 2y. I would minus the 14, and that's a negative 2. Divide by 2, and now this is where this gets tricky. You get y equals a negative 1. So when I write my parentheses, y is a negative 1. That's your second number. That's not your first number. So now I'm going to take this negative 1, and I'm going to plug it back in for y. So I would have x equals 4 times a negative 1 plus 7. So negative 4 plus 7 is 3. So my answer is 3, negative 1. So it doesn't matter. I'm just trying to show you, it doesn't matter if it's solved for x or y. I would do the easiest route. Like, if you don't want to solve for something if it's already solved. Okay, so now let's take a look at number 5. This is an important example because on number 5, neither one of them are solved. You can make your life easy or you can make your life hard. Okay, if I solve, like, if some people get so set, and I've taught algebra for 25 years, they're like, oh, I got to solve for y. Okay, if I solve for y, I'm going to have thirds and I'm going to have fractions, and no one likes fractions. So why not look at the problem and say, what is all by itself? Oh, this y. If I solve for that guy, all I have to do is minus 2x. So I get y equals a negative 2x minus 2. And now I have it solved, and I'm going to put it into the y. So when I put it into the y, I'd have 5x plus 3, and then minus 2x minus 2 is going in for the y. I'm substituting it. So I times by 3, so 5x minus 6x minus 6 equals a negative 8. These two are on the same side, so negative 1x. If I add the 6 and add the 6, I get a negative 1x equals a negative 2. Divide by a negative 1, and x equals 2. Right? So now I'm going to take that 2, and I'm going to substitute it back into there. So I would say negative 2 times 2 minus 2, which is a negative 4 minus 2. So my answer is a negative 6. These things hit at 2, negative 6. All right, so what I would like you to do right now is I would like you to pause the video, and I would like you to do number 6, just number 6. Pause. So if you take a couple seconds before you start number 6 and you make your life easier, this guy is already by itself. It doesn't have a number in front, so I'm not going to have to divide and end up with ugly fractions. So I'm going to minus 2x and minus 2x, and I am going to solve for y. Okay, I'm going to take that and I'm going to substitute it to the other equation. Do not substitute it back into itself. So like if I'm sick and I call for a substitute, I can't substitute for myself, right? If you're making cookies and the recipe calls for white sugar and you use white sugar, you didn't substitute, you just used it. So that's where you got to be careful. I got to put it into the other equation. So when I write that equation, where the y is, I'm going to write what's in that box. And then I would go 2x, I would multiply in, plus 6x minus 27 equals a negative 11. Like terms, so that's 8x. I would add the 27, and that's 16. Divide by 8, and my x equals 2. I need you to write these as a point. Do not write x equals y equals. I want you to write them as a point because they are a point. So I'm going to take that 2 and put it in there. So y equals a negative 2 times 2 plus 9. So that's a negative 4 plus 9. So my answer is 5. So the answer to this problem is 2, 5. Okay. All right. Now, I want to show you, and I had you not do 7 on purpose because 7's a kind of a doozy in a lot of different ways. First off, we have been solving for y since we started kind of working together, right? And so kids are like, solve for y, solve for y, solve for y. But if you look at this problem, this x is by itself. Like solving for y is going to give you a ton of extra work. So I'm going to minus 5y. I'm going to solve for x. So x equals a negative 5y plus 4. Okay, and I'm going to take this negative 5y plus 4 and I'm going to put it in for x. Okay, so I'm going to have 3 times a negative 5y plus 4 plus 15 equals a negative 1. Okay, so I would have a negative 15 if I multiply that in, negative 15y plus 12 plus 15y equals a negative 1. These are like terms, they cancel. You end up with 12 equals a negative 1. Does 12 equal a negative 1? No, it doesn't. So I'm going to go into, oops, just lost my pen. I'm going to just go into Desmos really quick, and I'm just going to show you how you can use Desmos on a question like this. I do not care if you're using Desmos to check your answers. Okay, but I would expect, like, when we do a test on this, you're going to have to show me you know how to do this. So I'm showing you kind of trick. So number 7 is x plus 5y equals, is that 4? Yeah. X plus 5y, x plus 5y equals 4. So it gives me that line, right? And then the other line is 3x plus 15y. 3x plus 15y equals a negative 1. So now if you look at those two lines, you can kind of see what's going on and why the 15y's canceled. They canceled because those lines are parallel. So when your y's or your x's, like in this problem, cancel out and you're just left with numbers, if the numbers are not equal to each other, then it's no solution. But that's not what I want you to write on this. I want you to write, these are parallel lines. Okay. All right. So I would like you to try number 8. Number 8 and number 8 only. I would like you to pause the video and try number 8. All right, so on number 8, to solve, this x is almost by itself, so I'm going to minus 4y, and I end up with x equals a negative 4y plus 0. I box it, and I draw a line to the x. I do the draw the line thing because over the years, you've watched me make mistakes all the time. I'll have it solve for x, and then I'll put it in for y, and it's a mess. So I got to remind myself I'm putting this in for x. So 3 parentheses, negative 4y plus 2y equals 20. So negative 12y plus 2y equals 20. So negative 10y equals 20. Divide both sides by a negative 10, and y equals a negative 2. So that's my second value in my coordinate, is a negative 2. So I'm going to take that negative 2, put it into here. I don't really need to write this down. Negative 4 times a negative 2 is 8. And I'm done. Okay. All right, so let's take a look at the next one. And if we're doing it together, that means, because it's tricky, okay, this y is almost by itself. So that's the one I'm going to solve for, because I can solve for anything. So I would make your life easier and solve for the one that's like almost solved. So this has to go into y. So I'm going to rewrite this 6x plus 3, parentheses negative 2x plus 18 equals 54. Okay, so if I multiply in, I get 6x minus 6x plus 18, 36, 54, plus 54 equals 54. These cancel. So I end up with 54 equals 54. So let's go back to Desmos on this one, because that I think is going to be helpful to you so you can see kind of what's going on. I'm going to delete these. And again, please don't use Desmos to just do these problems. I'm kind of teaching you how to check. I'm okay if you decide to type these in and check, but you've got to be able to do the math on this. 6x plus 3y equals 54. 6x plus 3y equals 54. There's one line. Okay, and then my other line is 2x plus y equals 18. So other line, 2x plus y equals 18. Whoa, what happened there? The green went away. Did it go away though? There's the green. There's the blue. Oh, they're on top of each other. So this, when they simplify and they're equal to each other, we did this in a past chapter. When they simplify and they're equal to each other, that would mean that it's all solutions. But that's not what I want you to write in this chapter, because all solutions means they are actually the same line. Okay, so if they cancel, if your variables cancel and they don't equal, like on number 7, they're parallel lines. If they cancel and they do equal, they're the same line. Okay, and if you get to one of those and you're not sure, you can go ahead and use Desmos and check it. But like I said, please be careful with Desmos. I've found that because you're going to have to take a test on it, and I'm not going to let you use Desmos on the test. So if you're using it to check, that's a wonderful idea. Okay? All right, I would like you to pause the video, and I would like you to do 10 and 11, both of them. Neither one of them is tricky, 10 and 11. So on 10, I'm going to make my life easier. This x is by itself, so I'm going to add 3y. And I get x equals 3y minus 2. So I'm going to take that, and I'm going to draw to this 10x, right? And so I get 10 parentheses 3y minus 2 plus 8y equals a negative 20. Multiply in, you get 30y minus 20 plus 8y equals a negative 20. Okay, so I'm going to put like terms together, and that's 38y. I add 20 to the other side, and kids are like, oh, it's no solution. No, my y's didn't cancel. You have a 0 there. You can divide by 38, and that's saying y equals 0. These actually hit at 0. And so I'm going to take the 0, plug it in. 3 times 0 is 0. 0 minus 2. So they hit here. So my y's did not cancel. That does not, you're not going to get all solutions or no solutions if they don't cancel. All right, on the last one. So if I minus 3x, you get a negative y equals a negative 3x minus 8. You can't have a negative y. So I'm going to divide everything by a negative 1, and I get 3x plus 8. So I'm going to take that, and I'm going to put that into y. So 5x plus 2 times 3x plus 8 equals 5. Multiply in, you get 6x plus 16 equals 5. So my like terms are 11x minus the 16, and you get a negative 11. Divide by 11, divide by 11, and x equals a negative 1. So x equals a negative 1. If I put the negative 1 into here, that's a negative 3 plus 8, which is 5. So those are my answers. So if you have trouble on this assignment, you need to let me know right away, because this is an important skill that we are doing.